How to make calculations of pH in solutions of strong acids and strong bases. First, let's take a look at the types of acids and bases. Let's take a look at the types of acids and bases. First, we have the Bronsted acids. These are proton donor substances. See that all the formulas have one or more hydrogens at the beginning of the formula. These are all Bronsted acids. And the Bronsted bases are proton receptors, substances that can receive a hydrogen ion because we have free pairs of electrons. There are also Lewis acids and bases. This definition is based on the capability to receive or donate pairs of electrons. To calculate pH of strong acids or strong bases, we will focus only on these substances that I circled in red here. These are strong acids, these are all weak, and the only strong base that we will use is the hydroxide, okay? So forget about the rest for now. What does it mean that an acid is strong or a base is strong? It means that they dissociate completely in water. Let's have a general formula for a strong acid. If we put 1 mole of acid in the water, at the beginning, we have nothing of the ions. But after the dissolution of the acid, there is nothing left of the molecular form of the acid. It is all separated in hydrogen ions and the anions. If it's a base, this M symbolizes a generic metal atom, for instance sodium. The base also will separate in its ions, the cation and the anion, the hydroxide, and there will be nothing left of the molecular form. What if the base has 2 or more of these anions? When it separates, when it ionizes, it gives 2 moles of anions. So we need to consider this 2 number to make then the calculations, all right? If it's a hydroxide with only 1 anion, all right, it's 1. The initial concentration will be equal to the concentration of the anions. But if the hydroxide has 2 or more anions, you need to double the initial concentration of the base in order to get the right concentration of OH ions. How do we calculate the pH of a strong acid? First, you have to know that the free protons in water will always combine with a molecule of water to form this species. It's called hydronium. The pH is minus the logarithm of the molarity of hydroniums, always in molarity. In dilute solutions, pH goes from 0 up to 14, and you know that 0 to 7 is an acid solution, 7 is neutral, and after 7 it is a basic solution. So how do we calculate the pH of a strong acid? This example, it's with nitric acid with a certain molarity. So if you look at the ionization of this acid, you know that it is strong, so it will separate completely. There will be nothing left of the molecular form. So the final concentration of the hydrogen ions will be equal to the concentration that the acid had originally. So all you have to do is minus the logarithm of the concentration of the acid, and that is the final pH. Alright, so remember, if you have a strong monoprotic acid, you don't need to do anything except the logarithm negative of the concentration of the acid. Alright, remember that pH is a non-dimensional value. There's no units for pH, it's always just the number. And the number of decimal places in the pH value should be equal to the significant figures in the logarithm. In this case, there are 1, 2, 3 significant figures it could be a third decimal place in here. I just chose to cut off at the second because that's enough to inform a pH. 2 decimals, it's okay. How do we calculate the pH of a strong base? If we have, for instance, sodium hydroxide, if we think about the ionization, it will separate completely in sodium cations and hydroxide. And what I am interested in the base to calculate the pH is the concentration of this anion. This is what will change the pH of the water. So I don't have hydroniums here to calculate pH directly. I have an excess of hydroxides. So first you calculate pOH, doing minus logarithm of the concentration of OH. And remember that in this case, the concentration of the anions it's the same. The concentration of the anions, it's the same as the initial concentration of the base, because there is only one anion per mole of the hydroxide. So you do pOH, and then to calculate the pH, you do 14 minus the pOH. And you see that this pH is high enough to call it a base. What if the base has 2 anions, like calcium hydroxide? In this case, when the hydroxide separates in cations and anions, we have 2 anions. So the final concentration of OH will be twice as much as the initial concentration of the base. So when you calculate pOH, it's minus logarithm of this number, not this. And to calculate pH, you do 14 minus pOH. And you'll see that this pH is a bit higher than the previous one. Look at the concentrations. The concentrations are the same, 0.002 and 0.002. The concentration is exactly the same, but the pH is a bit higher in the calcium hydroxide. That is because you have a larger concentration of OH anions. Thanks for watching, and you can like, comment, and subscribe.